Dear participants, good morning, sorry, good afternoon to everyone. Our resource person, Dr. Mr. K. Mahendran, is on progress of connecting a flow meter to show the data security. So he will be in joining the meeting within a few minutes. So please be patient till that. Ramya madam, are you ready?
Yes, sir.
First speaker has joined, I think. Sir, Mahendran sir? Mahendran sir, is it audible, sir? Can you hear my voice, sir? Your presentation is visible, sir. Mahendran sir, are you ready, sir?
Okay. Good afternoon, everyone. Hello, you can able to hear me? Hello.
Yes, sir, it's audible, sir. Good afternoon, sir.
Good afternoon. For the delay, we had some issue with the network. We got delayed.
Oh, it's okay,
Apologies
sir.
for
It's
that.
okay, sir. Nothing a problem, sir.
It's all
Nothing, sir. No need,
and,
sir.
fine, fine.
What is
It's okay. It's audible for us. And what about you, sir, from your end?
Yes, sir. Nothing is also visible. Nothing issue, sir. Before starting the session, I will sir.
Fine, sir. Sir, my name is Mahendran, and I'm associated with Base
Our
Electronics.
co-workers. Sir, Mahendra, our coordinator will give you an intro about yourself, sir.
Fine, sir. Fine, sir. Fine,
Okay,
sir.
okay,
Okay, fine, fine.
okay. Okay.
Yes, please proceed.
Welcome to everyone. All one, the good afternoon. Electronics manager from Base Electronics. Welcome you, sir. Mr. Sam will give you a
Okay. Good afternoon to one and all. I'm Ramya, co-coordinator of this program. It's my great privilege to welcome our chief guest, Mr. K. Mahendran, sir, who is having 25 years of global experience in petrochemical, oil gas, refinery, and LNG gas process industries in Gulf and India. He started his career in instrumentation maintenance department in Manali Petrochemical Company as trainee in 1992 to maintain process control instruments and control systems and handling instrumentation projects. He joined in Kuwait National Petroleum Company in 2002 as supervisor in instrument maintenance and technical services. He joined in Sohar Refinery Company in 2005 as supervisor in instrument maintenance and technical services. He joined in Qatar Gas Company in 2007 as supervisor in instrument maintenance and technical services. He joined in Qatar Gas Company in 2011 as supervisor in instrument maintenance and technical services. He is a process control instrument engineering solution provider to process industries through RM engineering and consultancy. And once again, I welcome you, sir. And I request you to take over the session. Thank you, sir.
Thank you, madam. Thank you, and welcome you all. We are from. So we are. I am representing Base Electronics for this session, and mainly we are going to talk about the Internet of Things, and many of you aware of the Internet of Things, and I no need to go for a long explanation about that, but I wanted to explain about the applications in industries, how it is associated, how it is very significant to the industries, and how and all it is helping the industries for the cost reduction, productivity, efficiency in production, and so on. Many things are like that. So just I will make a slideshow about the introduction of the Internet of Things, and we will go deep into that. So can I have slideshow? Anyone have the idea about the Internet of Things, sir? Am I all of you? Hello? And we can view all the data. This is the way we are connecting all the IoT things for our industrial applications. So this is why it is written the Internet of Things describes the network of physical objects like sensors, and it will be embedded with the IoT gateway, like a particular sensor, how it has to be coded, and so that it can communicate with the IoT gateway, and the data can be from sensor to IoT gateway and hosted to the cloud server. From cloud server, we can able to view all the data in monitoring software. This is way, so we try to explain here. So this is a sensor. Sensors means the measuring device, and the software for viewing the data from the sensor through IoT gateway. So this is the one about this. So this is, you can see the structure of IoT. Here we shown some kind of sensor like temperature. Then the blue color one is the flow meter. And the left side one is the dispenser. So fuel dispenser. So someone can remotely monitor. So someone say like some colleges having 20-30 buses in their compound. So they have one local fuel dispenser unit, and they are filling all the vehicles fueling. So this has to be monitored remotely for accounting purpose and efficiency analysis of the each driver and vehicle. This kind of data we can take from dispenser and through vehicle ID, and we can analysis. So for that, these dispensers will be connected to the gateway, IoT gateway. In this, we are using communication protocol as RS-232. So all the data like vehicle, each individual vehicle, fueling data, everything will be taken daily basis, yearly basis, monthly basis to make the analysis. All the dispenser will be data will be coded with the IoT gateway. That is called, we used to call embedding. So the hardware part will be the dispenser, and software part will be how it is connected with the gateway by means of coding. That is, we are talking about the embedding system. So once it is communicating with the gateway, and it is directly connected to internet through cloud server. So from that cloud server, we have some monitoring software. So that is shown in the right part of that image. So that is with the graphical display, we can able to see everything. What is the dispenser unit, how data like another, we have some storage fuel tank, that what is the level of that. If it comes low, then it will be communicated directly to the filling station through SMS. This kind of things automatically can be done. No need to have the information after getting the fuel low, informing them, and it's getting delayed. Its vehicle cannot be filled due to insufficient fuel level. This kind of things can be avoided due to this internet of things, where it can be used globally or anywhere remotely. So this is the advantage over there for our with this kind of things. We are giving solutions to the clients. So they are implementing slowly about this one also, even in colleges. So this is the network architecture of this one, IoT. So as so the IoT gateway can be connected. The sensors can be communicated with the IoT gateway. These are all the some protocols. It can be connected through Wi-Fi, Zigbee. That is one kind of protocol to connect with the IoT gateway. Data inputs through RS-485 or RS-232. This is also one communication protocol. See here we are using for fuel tank. We have one level probe. That level probe monitor the product level, water level, what is the temperature of the fuel, all together in one probe, and it will be communicating to the gateway through RS-232. So all the data from the level probe will be coded to communicate with the IoT gateway for the embedding purpose. From IoT, again it will be connected to the cloud. From there, we can have the web-based monitoring locally, and some kind of vehicle people are this vehicle also. We will have the tab to monitor about the things. So the driver also can view and communicate with the fuel dispensing unit or something like that. So this is the way it is. We are connecting to this level monitoring probe data to IoT gateway, also RS-485. So some kind of sensor can be connected to gateway through Bluetooth also. So through Bluetooth, it can communicate with the IoT gateway. And TCP/IP is, see, these are all the communication protocols for us, for the sensors or devices to communicate with the gateway, to export the data, to connect to host to the cloud server. I think everyone is understand, because I can't able to hear anybody being muted, I think. It's so I can go for the next. The, this is nothing but just a brief explanatory about the IoT structure building blocks. Every IoT system is different, but the foundation of each IoT architecture as well as general data process flow is roughly the same. What they are trying to say, suppose some data has to be exported from fuel dispensing unit to other monitoring station. For that, it will be a different architecture, and some kind of power data has to be monitored in different places remotely. For that, you will have the substation unit where the power is getting distributed, and we can view remotely. That kind of architecture will be different. So all will be same. That will have the sensor for measuring. Again, it will communicate with the gateway. Again, it will be hosted with the cloud server. Only thing, the sensor part will be different to measure the power consumption or what the water flow consumption or something. This is the way that's what they're trying to say. The architecture going to be the same, almost everything. Only the sensor part will be different and the coding will be different. That is the first point, is the explanatory. All the sensor obviously has to be embedded with the uh, IoT gateway through coding to communicate with that. That is the second point. So once the data is communicated with the IoT gateway, that collect all the data and connected and goes to the again cloud server, and from the cloud server we can able to see all the data in the monitoring through the monitor. That the dashboard will be there. That will have a separate software to view the monitoring all the data as customized as per the requirement. So all the data from the sensor will be can be seen in the dashboard remotely, or we can connect it to the web-based monitoring also. So this is the way, this is the blocks, what we have: the sensor part, IoT part, cloud server, and the monitoring. These are the four stages we have in the IoT. The first stage is sensor. Again, I am repeating, the first stage is sensor. Again, it will be embedded with the IoT gateway, and the gateway is the second part, and third part is hosting with the cloud server. The fourth part will be connected to, we can view all the data in the monitoring software, which can be customized as per our requirement. These four stages are explained here with the different building block structures. That is the page. It is a self-explanatory, and what also more than that, I just briefed about that. I hope you understand, and I can move to next one. Okay, these IoT applications, many of you know, it is for many things we are going for this IoT. Uh, the first is wearables. What it means, example, some passion, some individuals is there. They have the threat of heart attack and high BP and some their BP and sugar level and other things should be continuously monitored. But they can move around easily. They no need to be in inpatient. For that, anytime they can get a threat of IBP or something like that. So we can wear the sensor with the wearing staff. Then they can be tracked through GPRS. So anything they have something, they will be connected. This if their health conditions exceed the permittable limits, it will directly will communicate with the closed ones or the family doctor, so that immediately he can be accessed and attended. This kind of things also. This again, where the strap where they are wearing, that will be sensing all the like heartbeat, high blood sugar, and blood pressure, all these things. This what is that? Calorie level also. This tracking belts they can wear, and they can get all these things. And the GPRS will say where there's location, where they got problem, where they held up, so that the family doctor or closed one, they can attend immediately and take to them to the hospital. This is one way of wearables that is also used through IoT applications only. Next one is health. The health is also, there are many patients in the hospital who will be inpatient. The doctor cannot be always with them. So doctor will be in his place, and any patients having high risk and that particular data has to be monitored continuously. If they are exceeding their threshold limits, their health condition, immediately it will give the alert to the doctor to attend the patient immediately. So that is the way it helps the patient in hospitals. That is the health. So the traffic monitoring also same thing. So it will be useful to vehicle traffic in large cities, contributing to the concept of smart cities. So the same way. And another main important thing is smart grid and energy saving. That is the very important thing nowadays. There are two concepts in power management. One is encouraging the industrials and consumers, residential consumers, use the natural resources for the power. That is one way. And another way, optimize the power consumption. How it can be optimized? So suppose if you take in home, there won't be any people inside the room or hall. The unnecessarily the light will be on and other devices might have on. This is one way. Like that in industry, what will happen? One equipment will be running ideally. When required, it will take a load and deliver the um, liquid or gas to the process. When not required, it will run ideally for some time. This will have the power consumption. This kind of things we have to analyze particular equipment, how long it is run for with loading condition, how it is run with the ideal condition. This and all can be monitored through current consumption from the particular equipment. All this can be viewed through intelligent meters. That intelligent meters can be connected with the IoT gateway and it can be remotely monitored. If for particular equipment running ideally for more than 15 minutes for nothing, it can give the alert to this kind of things can be monitored and analyzed. So we can make a schedule if the particular equipment running ideal more than 5 minutes. It can go to standby mode, it can stop, and it can start when demand required by the process. So that this way the power can be consumption can be reduced. For that, we have to aggressively vigilance about the power consumption of the each equipment while it is running. It's running unnecessarily or it's running ideally for many times. This kind of things can be monitored by the power consumption through current data. That current data will be given by the smart meters, which is connected to the particular rotating equipment. So this is the way the power can be managed to reduce the consumption. It not only reducing our cost, it's helping to prevent the environment, because if you need more power, we are producing more and it will have impact on environment. So many things are interconnected. So this is the way it can help. So we cannot be always sit in front of that power distribution panel, how the whether it is running ideally like that. So all will be connected to the cloud server when we will have some set values. So suppose when it is running, it is 50 amps. It is taking current means. So 30 amps is the ideal condition. You can set as a example. That 30 amps, if it is running for more than 10 minutes, it can be given alert to the particular people so that all the events will be recorded. It can be analyzed next day. So this kind of findings we can make it, and we can we can optimize those powers, and we can make the reduced power consumption in industry as well as in the residential. So this way, the IoT helps for the energy saving. How it helps? Again, the smart meters connected with the IoT gateway. From there, it will be data will be connected to the cloud server. Then it will be viewed, and we can set the threshold limits also. Suppose it's exceeding more than 1 hour. Suppose it's coming less current, means ideal running. These kind of things will have the alert notification to the people. So somebody will know this equipment is running more than half an hour with ideal condition. So this way it can be helpful to the power consumption. This is the basic architecture of that water meter consumption data. So in the high-rise building, we will have the individual water meters for individual residential people. Inlet of that each house, we will have the water flow meter. That water film, suppose, see, nowadays we are, our vision to the government, Indian government as well as Tamil Nadu government, they want to go for the smart city. Like they implemented in parking system in Pandi Bazar, I believe everyone aware of that. The same way, they want to see the consumption of water due to water scarcity. Maybe this will show any leak in the water system or the behavior of the consumers. If they are using more water or something like that, all can be monitored in the water flow meter data. So again, all the water flow meters connected to the cloud server through gateway, and it can be monitored in the water authority in this end. Also, it can be used for the billing purpose. The particular X consumer utilized consumed this many water, and it has to be billed like this as per his consumption. This kind of things can be useful through IoT network. So this is the general arrangement how it is connected with the water authority for the individual consumers water consumption. Um, everyone is okay with that, what I am telling? Or I am going speed, or can someone give me feedback?
Sir, it's okay, sir.
So you can able to follow. I am going a little bit speed or little confusion or something like that.
Nothing, sir. Nothing. No issue, sir.
Yeah, everyone is comfortable, sir.
Yes, sir. Yes, sir.
Okay. So this is understandable, no? This block diagram. So for this, we implemented the same thing in one in CSIR project. We done it. You can see the block diagram. See there, we have the raw water. In the raw water, the inlet of the raw water, water quality parameters can be analyzed like pH, TDS, turbidity, all these things before going to RO unit. After processing the water with RO unit, after treating with RO unit, again the water quality parameters in the downstream. This completely controlled by the programmable logic controller. This is the control system in PLC. Then that data that PLC is capable of exporting the data to cloud servers through internet. So that we implemented this one. We had one after the RO unit. We had one distribution line, about 10 lines. We had individual flow meters, and all the data are exported to cloud through gateway. Also, the water quality parameters from inlet of RO system and outlet of RO system. All the data are controlled by the PLC, and the data are exported to internet for viewing and analyzing purposes, and also building purposes. This kind of project we implemented in CSIR through our base electronic system only. This is the arrangement we made it. This is the graphic, block diagram presentation of that particular project. So we can able to see some sensors incorporated for monitoring the water quality in the inlet of RO system as well as outlet of RO system. All sensors are connected to the PLC below that through hardwired. This all hardwired can see, measure the can get the signal from sensors and it can control the complete process unit, and parallelly it will export all the data in real time to the cloud server. So this is the remote monitoring. You can see the graphical representation of the all the data. So here it is connected like directly, but it is not the case. So it is connected to the cloud server through gateway. That PLC we used that is capable of exporting all the things, all the data to the cloud server for remote monitoring. Okay, sir, we can show some example of the software, how it can be monitored. I asked Mr. Pradeep to show you the software. He can brief about it a little bit, how we can view in the remote. I'm just handing over for software session to Mr. Pradeep, Base Electronics.
Hello, good afternoon to everybody. This is Pradeep, Assistant Manager for Projects and Product Development. This is one of the software how normally this IoT machines will communicate with that server, and that from the server we have for customer how we are replicating our data for the example purpose. I am showing this software and what are the features available in that one. If you consider one high-rise building, in this particular apartment, nearly 43 numbers of different locations are there. Every location we have given one separate name, username, and the user mobile number and the mail ID, and each user how much he is consuming the water. He can through the software he can see there every month. Example, how much water he consumed in January, how much, and March, and also he can export the data. Example, using the Excel format.
So this is the monitoring software. So individual data can be exported to in Excel format, like what we are seeing in the screen. Every month we can take it, and how much he consumed, what total water consumption, initial reading and final reading about that particular consumer, the total reading, what is the period we taken for that particular consumer. This kind of things we can export from that software directly. This is what the format. So it can be for analysis also. Also, we can see the behavior of that particular consumer is lavishly using the water or something like that. It more than that, we can analyze some more thing. Suppose somewhere the pipe break, and we have the lot of water flow consumption, but individuals don't have that much consumption. That means in between somewhere the pipe got break and the water is going outside instead of going to the consumer end. This kind of this kind of problems also we can able to identify through flow meters. So how it can be done? The flow meter can be incorporated in the distribution network end also in consumer end. if consumer end not having that much consumption flow and distributor end having more consumption flow, means in between somewhere we got some pipe breakage and the water is going outside instead of going to the consumer end. So that by means of that flow reading, we can able to analyze this kind of fault identification, and we can attend immediately to prevent loss of wastage of water. So these are all advantages for using this network through IoT for the water authority. So once it can be automatically built by the software billing software, how much tariff and how much he consumed for the particular month, as per tariff how much he has to be charged, and the billing automatically it will go to the individual consumers. So for that we need to know how much consumption for the individual consumers. So for that we will measure that consumption through a water flow meter. That particular water flow meter will be connected to IoT gateway through embedding and coding. So that again it will be hosted to the client server, cloud server. Again it will be monitored in the dashboard remotely. And based on the data from that cloud server, we can have develop the separate software for individual consumption data as per tariff for billing purpose and behavior of the individual customer for excessive consumption of the water. So like that, so many advantages are there. As I said before, in any kind of pipe breakage also, we can able to identify by the water reading, water flow meter reading. Either, as I explained before, we have more reading in the network end, and we don't have much consumption reading in the consumer end. In that, by comparing this reading, we can able to identify this. So these are all the advantages our IoT implementation in the water distribution network. So the same we developed a pilot project and implemented successfully in the CSIR for study purpose and the implementation throughout their state, especially in the remote areas. So this is the one. So same with we explained this water sensor supply. Just now we talked about that. More than that, we have the maintenance management also. As I said, the pipe breakage we can identify. Also, some kind of suppose some particular pump was running suddenly not running due to some electrical failure or any other thing. All can be made alert through SMS to the maintenance people. Suppose the pump was running, suddenly it has got stopped. So that can be sent to the maintenance personnel. The particular pump got stopped, so the water distribution has interrupted. So that he can go immediately and attend that particular fault, and he can make sure that it is again re-established, everything. So, so how the maintenance management work with the IoT? See, we already from water flow meter or particular pumps or sensor, all the data are exported. Already we are viewing. Suppose particular data, but we will have some set point or some status of running or not running. This and all we can put as a alert notification. If it is running, we won't have any notification. If it is stopped, we will have notification to the people. And suppose the excessive consumption also, it will notify to the people. Less consumption also, due to some problem, it will notify to the maintenance people. So that he can get the alert through SMS. That kind of facilities, we can make it. From data, we can put the threshold limit or status limit, and based on that it will generate automatically the alert notification to the particular maintenance personnel through SMS, or even he can have the mail notification also if he is sitting in office. So both way it can be communicated to the maintenance personnel automatically. So the earlier detection of the problems and the earlier rectification of the problems can be done through this kind of system. So you understood, sir, what how it is working in our industries, especially in water authorities and power management, and how it is connected with the control system. So everyone is understand, or we can have explanation more, sir. Can anyone respond for this?
Yes, sir.
Yes, sir. Okay, is it okay, sir?
Yes, sir. It's okay, sir. No issue, sir.
Okay, now we will show our IoT embedding engineer will show you the hardware part of that system. But you can able to see. You can able to see the monitor, sir. You can able to see my face.
Yes, sir.
Okay, that is he will show. You will turn the camera. He can explain you what is our.
Participants, please pin the base accounts camera view. Then only you can able to see it.
Sir, for you okay?
Yes, sir. It's visible, sir.
Yes,
sir.
Yeah, is it visible for you?
Yes, sir.
Yeah, I'm Ramaswamy from Base Electronics. Actually, here we having hardware board that is ultrasonic flow meter. In this ultrasonic flow meter, it takes 220 volts as a input and Wi-Fi output. In this RS485, we collect the data from ultrasonic flow meter and temperature sensor. This sensor will collect the output by using RS485 and give the input to the IoT gateway. This IoT gateway we need send to the data into server side. That server side will be the data will be stored in server, and that stored data will be replicated on PC periodically. Actually, within period of time, they take data and that stored in server and should be.
Just I would like to add some points with Ramasamy. So what he's trying to explain is this is the hardware unit for the flow meter for measuring the flow for the individual particular line. Okay, this is the part of it. Then this part has to be interfaced with the IoT gateway for embedding or coding the particular data to the IoT gateway. This is we are using as a IoT gateway. This communication protocol, as we explained before, this is one type of protocol is RS485, right? RS485 from that flow meter unit to this IoT gateway. This will be interfaced through RS485 communication protocol, so that all the data will be embedded here through coding, so that from here we will have connected to, it will be hosted to the cloud server for remote monitoring. This is the way it is. So we explained everything before. We practically showing our hardware part, how it is interfaced and how it is connected. This part will be directly equipped with the sensor, directly connected with the line, where it has to be measured by the, where we have to measure the flow for that particular line. Water flow, or it can be any flow, no problem. So this is the way, this is the flow meter part. and interfaced with the gateway through RS-485. Then we will have the embedding through coding. Then it will be hosted to the server and remotely, as we shown the software. So it will take all the data and it can be viewed here. So by means of data, they can have the separate another software for calculate the consumption of the individuals and the billing purposes. This is the way it works in water authority. Suppose it is in power management, all the other part will be going to be the same. Here we will have the intelligent meter where it can measure the particular power distribution, power, voltage, current consumption, everything. All data again it will be communicated to the gateway by the particular communication protocol. It can be even serial link, or it can be even TCP/IP again. So initially we talked about the different architecture, but concept will be the same. Here the architecture will be with the flow meter, the initial part. There if you take the power consumption, instead of this flow meter unit, we will have the intelligent meter where it can measure the particular electrical equipment of power consumption, what current and voltage. Again, all the data will be communicated to the gateway. The gateway will be same. Again, the cloud server will be same, and the monitoring software will be the same. Only we can customize the monitoring software to view the data according to the input from power or according input from flow meters, like that. As base flow meter. So this is the one kind of flow meter. It is the actually the electronic unit. We will show you the sensor also now, which is connected with the pipeline for measuring the flow. Sir, I think you are having some issue. You can't able to view properly. So we are taking one more time. Okay. So you can show. Mr. Ramasamy, you can show to them.
This is the water flow meter. In this water flow meter, we can measure flow rate and how much quantity of water is flowing based on hourly, weekly, and we can predict that our consumption when we put it in line only. It is used in IoT module is inside that unit only.
So this two pipeline. Okay, you just put it. I hope everybody is seeing this one. It's okay, no? Okay. Okay. So you just Ramasamy, hold it like this. So this is the local reading we are having, and this is the pipeline connection. So it will take all the measuring data. It can measure all the flow data, and we have some interface communication protocol to interface with the IoT here, IoT gateway. So it will have separate power, and then it will have one communication protocol connect with the IoT gateway interface, so that all the measured data will be connected to the IoT gateway. You are seeing in picture that one also, the back side. That is the one. So from there, it will be hosted to the cloud server.
This whole flow meter. In this flow meter, we having.
That is one kind of flow meter. This is another one kind of flow meter. These are all our products. So for different water applications, suppose it is water, we can use. It is the oil means that will be a different mechanism will be there to take to manage the oil viscosity to measure the flow. So this kind of things will be there. All will have the protocol to interface with the IoT. Different protocol it can be. It can be RS-232, it can be RS-485 to communicate with the gateway. Or even we have some Wi-Fi option also to communicate with the nearest gateway. So this is the gateway we are using for that this water applications. This is the flow sensors. This is also one kind of flow sensor only. And this is our hardware unit. Once the flow measured here, all the data will be processed here, and it will be interfaced with the IoT gateway here. Huh? So this is the level indicator also. The level probe will be connected, and they will have the indication in this, and from here it will be communicated with the IoT gateway. This is one type of indication. This is another type of indication and controller. All are base products only, base electronics product only. From there, it is again going to be interfaced with the gateway for embedding and hosting to the cloud server. This is the controlling part. This kind of things, it's having control as well as local indication. Also, it can be interfaced with the IoT gateway for remote monitoring. This is the capable of all these things. This particular electronic device used to call as controller for us. It's a pH transmitter particularly for this. So we are talking about the water quality parameters measuring. In that we used this. This is the one. This unit is for flow meter. And this is the flow sensor, which we are. This is the flow sensor, one type of flow sensor. This is also another type of flow sensor. So everyone understood this.
Yes, sir. Clearly, sir.
It's clear, no, sir. So why we
Yes, sir.
shown two different flow sensors? See, water means it's having less viscous and it can easily flow. And if it is oil, it having high viscous and it won't
Yes, sir.
easily flow. Accordingly, our flow meter mechanism will be different to manage the viscous of the liquid. So we are using different kind of sensors to measure the flow. That's what we shown two different flow. All the flow meters can be connected with the local indicating controller, and those controllers having capability to interface with the IoT system. So why someone will have doubt? Okay, water it's easily can be done. Suppose I want to measure in oil, it will have the different flow meter. Whether it can be capable of it will be having compatibility to interface with IoT. So for that purpose, we explained two different kind of flow sensors to managing the liquid based on the viscosity. For those for that only we have. This is another kind of smart ultrasonic flow meter. This is also one. Everything is integrated unit. Here we will be having sensor separate and processing that amplifying unit will be separate. Okay, this is the one. So also this is another to be explained. This unit will be having all will be integrated. It will measure, it will process all the signals, and it will be directly interfaced with the IoT gateway directly. So here you can see all these things.
Smart
Communication.
RS485.
This is communication will be RS485. So where we can, from there we can take out and directly connect with the IoT gateway module to take the data from this flow meter and connect it to the cloud. This is the one more part. This is what is the difference between here and here is this: the sensor is part is separate and the amplifying separate.
This work
The
on
processing.
this sensor is work with Hall effect. This electromagnetic field, it will be inside is there. It will do based upon positive pulse and negative pulse. It will get output to RS485 to the IoT module, and will get out and will get output in this module, and will store by using RS485. By using gateway, it will be stored in server. by in that server. After that, it will monitor in dashboards. Actually,
No, it's shown already. Yeah.
then anything.
So I hope you understand the difference between different flow meters. One is for the viscosity based flow measurement. Another one is for the smart flow meter will be having an electronic unit on the top of the flow meter itself. It is can handle a different kind of environment because that particular housing can be with the different certifications to handle the different environment. So all data will be processed here itself, and it will be interfaced through RS485 to the gateway. So this is the integrated part of the unit. So no need to have separate unit and connect the wire with them, and from there it is connected to IoT. So different depends on the client requirement and the consumer requirement, that user requirement. We have the different range of products. Ultimately, all the products will have the capability, the compatibility to interface with the IoT unit, IoT module. Is it clear, sir?
Yes, sir.
Okay. Anybody having some kind of detailed explanation more than this, let me know so that I can talk about even deeper.
I think no one is having any doubts, sir.
Okay. So, what I want to know, so today, okay. So our major is covered with not only with the IoT, and the IoT, how it is will be helpful in the industry's application. The major part we covered with especially for the water. Why we had more emphasis on the water? Because the government vision to have the smart city throughout India. That the smart city, one of the agenda is for the smart flow metering system to calculate the consumption of the individuals, to analyze the individual's behavior, and billing as per the consumption. This and all can be done. Suppose in Chennai itself we have lakhs of houses. It's not practical put to cable and connect with the local system to take the reading from the particular water reading from the particular consumer. So this kind of IoT, no need to have any wired system. This flow meter can be kept inside the house, or even in the complex, or in the hospitals, or in the anywhere else. So it can measure all the consumption of the water, and it will be connect to the authorities through remote monitoring, through IoT by means of remote monitoring. From once we receive all the data, they can have the separate software to calculate the consumption and billing everything. This is the way the water consumption works for the individual's billing. Okay, sir. That is the way how it is connected. We explained clearly about that now. So suppose in Ramachandra we have one college. They are also implemented, I believe, all these kind of systems. They have the ultrasonic flow meter. The same thing we in our Chennai city we have individual houses all having metro water connection. So now we don't have anything to measure how much they are consuming. Individual consumers, how much they are consuming, whether they are wasting the water, all invariably based on the number of houses inside the complex. We are generally putting the billing. Some may be having less, some having maybe less consumption, some may be having more consumption, but the billing will be same for the all. This can be changed. It can be built according to the consumed water consumption and billing according to that. So this kind of requirements can be fulfilled with this kind of arrangements. So that is why we emphasized more on the water data exporting to the cloud for these applications. Is it clear, sir?
Yes, sir.
Okay, sir. So if nothing is there, even I can close it, or if something needed, also I can explain more.
So any control process is there, sir, through using IoT?
Yes, sir. Actually, we use full duplex communication by using RS.
No, one thing we can. So okay, fine, sir. 1 minute, 1 minute. No. We developed one design recently. Okay, for that particular one consumer asked for this. Even we can say openly, like colleges, they are having around 20 buses. They don't want to fill the fuel in the different petrol stations, so they want to put one local filling station. That filling station, fuel filling can be done from externally, and for that they need to have one filling station. Also, they want to monitor individual vehicle filling data as well as the driver performance and everything. How we designed, we had one big unit with fuel dispensing as well as the fuel tank. Okay, the fuel tank can be continuously monitored, and it can give alert to the filling authority on the low fuel level by the um, by the level probe. That is one part. The level probe is communicating with the IoT through RS-232 communication, and we have one dispenser unit that is communicating with IoT um, through RS-485. These two things are communicated, and we have the dashboard separate software to monitor all these things. So for that, this is one part we are receiving data. As you asked for how it is getting controlled. So the vehicle, individual vehicle have the subscription by means of the vehicle number. So once we enter the vehicle number, we can fill how much kilometers the vehicle has run, how much fuel now it is required. So from there, by viewing the data, the admin will have control on whether to allow the for refueling or how it can stop the refueling on emergency. Two things are there. See, he can stop from refueling based on the data, and he can give command to proceed for filling the fuel for particular vehicle from the dashboard itself. So that from dashboard you will have command to control the dispenser for stop filling as well as start filling also. This way it can be controlled. This is one way of application from controlling from the monitoring software to here. This is one example for controlling the purpose. The another thing, sir.
I will explain another thing, sir. Actually, this having inlet and outlet, there's valve close and out. This mission having some certain protocol is there. Based upon protocol, we using based upon based upon protocol, we using that giving command and software. If you give command and software, means it will be closed automatically by using software. It is full duplex communication. If you give communication done on two ways, as an from hardware and from monitoring station, we can give this communication. With help of this only, we can control this device with help of certain protocols.
I'm adding to that, sir. What is trying to convey? Suppose that it's having high flow and the consumer end low flow. That means the water is in between, somewhere it is going out. That's why it is showing high flow. Immediately you want to stop the water flow to avoid the wastage of water. So from monitoring station, he can give one command that upstream of that this water flow meter, we will be having one valve. From that monitoring station, by the monitoring software, he can give the command. That command will close the valve immediately, the inlet of that flow meter. By using like a relay control panel or whatever it may be. The command will be coming from remote monitoring station only. That is another way of example for the control actions. So, example I am telling, somewhere the pipe got breaked, the water is flowing more. Someone has to go and close the water valve, till that the water will be continuously wasting. So instead of that, he already identified some problem with that particular distribution line. He can able to see in the monitor, he can able to analyze there is some problem. So immediately he can give one command to close the particular line inlet valve remotely, so that it will receive the command and the valve get closed automatically, so that the wastage of water can be avoided. The quick action can be done. This is one way of controlling from the monitoring software to the receiving end. So it can be achieved through duplex communication. Duplex communication means it can receive the data as well as it send the data to the sensor or devices for controlling purposes. This is one way. One way of example I told. Is it clear, sir, now?
Yes, sir. Can you do this simultaneous process?
Correct.
Okay.
We can not only we can view the things, we can even able. So another way, one example, sir. This is a very easy example. Suppose you are traveling by a car, and after half an hour you will reach home. And in the meantime, you want to be the AC on, and it can be your house should be cooled condition when you are entering to the house. So we can have one smart socket for the AC on off, and it can be connected to the IoT gateway. Through IoT gateway, we can see we can send the command from your mobile, so that it will directly on your AC inside your house. When you reach your house after half an hour, it will be in cool condition. So rather than going inside the home and waiting for getting cooled. So this is also one of the examples for control. Also, you forget to switch off the AC, gone out and gone to office. Rather than it is running without any man inside, without any people inside, you can see whether it is running or not. If it is running without any people inside, you can switch off remotely also. This is one example for power consumption. In a rush, we can miss out something. Not only AC, other electrical apparatus, we forget to switch off and simply left. So that we can do, by monitoring this, we can switch off remotely. That is another example of control action. It can be achieved, as I mentioned before, by duplex communication. Duplex communication means it can receive data, it can send data.
Yes, sir. Recent applications of ACs and everything is having the same, sir. So
Yes.
Wi-Fi, they have the Wi-Fi, we can able to control it through mobile phone.
Yes, exactly, sir. Exactly. The Wi-Fi is the one of the communication to the gateway with the devices. If we don't have Wi-Fi also, there is another way of interfacing the particular device to the IoT gateway. As I explained before, not only Wi-Fi, it can be even Bluetooth, it can be even Zigbee, it can be even TCP/IP, it can be even serial communication. So all communication protocol can be interfaced with the IoT gateway. Not only Wi-Fi. Wi-Fi is one of the communication protocol to communicate the device with the IoT for exporting.
A radio signal, you can say that.
Yeah, radio signal, exactly. That can be even done. That also we implemented in Zoho project. Some level kind of sensor, if it got to a high level, it will directly communicate with the dashboard through radio frequency only.
Yes.
To the gateway. From gateway, it will be connected to remote monitoring station by means of IoT. Is it okay, sir?
Yes, sir. Yes, sir.
Any other things, sir? Any other questions, if anything? So more than so summarize that the IoT what we explained today is the water authority for consumption and building behavior of the consumer and identifying the water wastage. That IoT is the playing the major role for this kind of things. It is the one of the vision to implement this for the smart city application. It is the application for the smart city. Our government, the Modi government has, the central government has the vision to implement the smart city throughout India, one by one, slowly. That is one of the agenda is to implementing that smart water meters through this IoT network. That's why we done this one. The second major vision is for the power consumption. Also, one more thing is that sir. We have many dustbin. It can be unattended. It will be overfilled, and no one clear that one. It is overfilled, and it's already spreaded all over the road. Also, it is smelling more and affecting the people, spreading the disease. Many things are there. For that, one of the thing is nowadays the smart bin is coming. The
Smart bin technology.
smart bin, yeah, smart bin. That smart bin how it helps. If it is overfilled, it will give alert notification to the local authority to clear that overfilling of the dustbin. That is one bit. The another way, that smart bin where it is located, the people who want to clear that overfilling from that dustbin. He can locate through GPRS where is that bin located, and he can easily access that bin. It can say the number one bin in so and so road got overfilled. This can give this much description only. But where it is exactly that corporation people can access easily through that GPRS. That is the smart bin application. So that is also again that sensor is connected to local gateway, and again it is connected to cloud. The same way it is happening. So this is also one of the requirement for smart city